good afternoon or good evening, everyone. My name is Salah Sakari. I'm from the University of Sydney. And in these 10 minutes, I'm just going to present to you kind of how we led into the process of autonomous soft fruit harvesting. But I do recommend that you see the video from Jasper Brown, who just finished his PhD on this topic area. So I'd like to thank the organisers as well for this opportunity. It's a great way to kind of bring the community together in seeing the different activity that's going on around the world. The main thing that I wanted to kind of start with was when we looked at harvesting and using soft grippers and soft fruit in general, and what was leading up to that, we looked at the entirety of the process from the bud formation all the way through to harvesting, because we were not just interested in fruit harvesting but also selective fruit harvesting. So what part of the orchard should be ready to harvest and which part of the tree as well. So we looked at the overall process, and that helped us kind of put together the overall piece of technology, not just looking at the gripper. So when you look at Jasper Brown's video on YouTube, you'll see the end goal, but I just, in this particular activity, I wanted to kind of lead through the process. And the reason why that was important was because in order to get to that point of harvesting, we needed to go through the steps with the growers and look at different aspects of their farm production cycle to understand where the perception system as well as the control system would work. So originally we had this robot. It was just a Segway unit where we put a whole bunch of different sensors on board, and we started to look at different aspects of what you saw in a tree and the different types of sensing information and what was relevant. You know, was it hyperspectral, was it laser, LiDAR, vision, thermal, or a mixture of those in between. So that was the kind of key elements that we wanted to focus on. This is just a video showing the output of one of those activities, which was in real time, could you detect fruit and target fruit? And in this case here, what frequency could you do that? So this is detecting apples in this particular case in real time, and then you can just see there a little water squirter that's firing at each individual apple as it's coming through. And what that basically gave us was a combination of a robot moving in real time, detecting fruit in real time, trying to count fruit as well, even when there was occlusion, like you can see in this particular area, and then being able to target, so that we wanted to get a relative coordinate frame running in real time as the robot was running through. And that helped us kind of get to that next level of harvesting as well. But that became the key element there. So we looked at relative harvesting, so being able to just kind of between eye and arm kind of robotic technology. So this is just some, these are all plastics, so they're not real, but can you do real-time detection, and from real-time detection being able to do real-time harvesting. So it's some of the first lab experiments that we went through. And it was, what was key here was, obviously you're trying to look at lighting, coordination, being able to detect fruit, being able to determine the bounding box around the fruit, being able to position the robot, and then when you go to harvest, you have movement as well that's happening with the tree. And so, what do you need to do in terms of being able to adjust to that? Same thing with, in this case, the oranges, maybe slightly quicker now, getting a bit better. Being able to kind of look at harvesting and where do you place and where do you kind of move on that element. So it was really just trying to look at the different techniques that were applicable in harvesting and what that looked like. And in this particular case, again, trying to run in real time, trying to determine the appropriate configuration of the robotic arm, what angle to come in at, what happens when you grab, how does that move, the motion and the movement of the tree in this particular case again, and being able to harvest that. Some earlier work, which was also very relevant, was in the information gain process and being able to look at what was the appropriate angle to come in at and identify individual fruit. So what's happening here is that we're looking at near-infrared and being able to look at depth information, and the fact that there's occlusion that's happening between the fruit as well as the foliage on the fruit, and hence what is the right angle to come in. So this arm now is moving in according to the information gain process. So we use Gaussian mixture models to try and determine the shape of the objects that we're looking at, and then turning the Gaussian information uncertainty into into an action, so to minimize that uncertainty or to maximize the amount of information. So the robotic arm would be moving accordingly in real time to try and minimize the uncertainty that was caused by the occlusion, whether it was between the tree, between fruit on fruit, or whether it was between the foliage on fruit. So if we could come along and determine the shape of an object, determine the uncertainty around our understanding of the shape of the object, then what was the correct angle and positioning of the sensor frame in order to minimize that uncertainty. And that helped us kind of understand a bit more about occlusion. And so then what we ended up happening was this process of being able to go from relative coordinate frames, being able to detect fruit in real time, being able to determine the location of the fruit in real time, and then being able to deal with aspects around uncertainty and occlusion as well. And then we looked at some soft gripper harvesting, and this was just trying to understand what was needed, what was required if you kind of started to bring all these things together. So if you started to look at occlusion, if you started to look at occlusion as well as, let's jump a little bit ahead. If you started to look at occlusion as well as the positioning of the robotic arm, where it was, what would happen to the tree or when you started to harvest, and then what was the right angle given the different types of gripper configurations that you would see, then it kind of gave you a perspective of the overall activity from, again, from detection all the way through understanding occlusion, and then what was the right positioning of the gripper frame. So in Jasper's work, which this is my last slide, but in Jasper's work, you'll see this all coming together. We basically just took a robotic arm out into the field. This was kind of part of the process of trying to detect that initial work. Take the robot out in the field. This is Jasper here taking a photo of the system, and the robotic arms on top. And then what we looked at was different types of soft grippers. So we actually started to build our own little soft grippers. Just to kind of see what would work in there. So and this was looking at summer fruit. And trying to position the robotic arm in real time outdoors, which was, you can imagine, it's a difficult task in order to be able to look at different aspects of harvesting. And Jasper talks a little bit about where it failed, what the issues were, especially around being able to grab the fruit in a way that you weren't going to damage the fruit on leaving, on removing the fruit, so that wouldn't scratch up, because this is quite delicate fruit, as well as the type of grippers that we used. And what happened to those grippers? So what would happen in real time as you would try and grab the fruit and remove the fruit from the tree. So this is just showing you all the different approaches coming together. And as I mentioned before, when you see Jasper's thesis, you'll see where it worked and where it didn't work, and what the issues were. So in Jasper's video, what in this particular case here, being able to kind of detect the fruit, but the foliage got in the way, and so you didn't weren't quite able to remove the fruit properly. So that's it. Like I said, I recommend that you see Jasper's thesis, and that will help understand a little bit more about the activity that was there. I thank you for the time, and thank you for the opportunity. I had to show it as a video because I'm out in the field and I was just worried a little bit about internet connectivity. So I thought I'd show the video and have the video present the work that we're doing, but happy to answer any questions. Thank you.